Hi, this is Billy Adkins. I'm submitting my YouTube video for the assignment two for Introduction to Machine Learning using the MLP cures using the hyperparameter grid search using PyTorch and Torch Vision. So we have pre-processing and then the hyperparameters, and then we don't need to worry about the homework tutorial. It's pretty much coming from the homework tutorial, to be honest, and changing some of the different things that match the assignment instructions. So we imported all of the libraries here and that we'll use. And let's see. And then this is the device. So this is actually checking to make sure you're using the GPU. And then if not, you use the CPU. It's available. So if I'm using the T4, I believe, for my runtime environment, and you can default it's Python 3, or default it uses your CPU, but you can change it. So I switched it to the T4 tensor. And then I have a new variable that contains the SciFar 100 data set. We did have where you use it in Pickle, but I actually was looking through the Vision Torch documentation, saw that SciFar 100 was already in there. And just to make it match the code a little bit better from the tutorial and the instructions, I just decided to implement SciFar 100 here. And then this is building the X-train and Y-train data set for a 255 pixel image. So you see it's just built, and this is printing the Y-train and the Y-test labels. So as you remember from our last homework assignment, X-train is the data that we're training, and then the Y is the label, the answer to the or I guess you if you want to do it, the cheat sheet or the answer to the data, to the train data. So this part is flattening into a 1D array because it has to all be the same size. So we're flattening and reshaping it into a one-dimensional array using this code. And this is printing, so we had 50,000 training samples and then 10,000 test samples. So, um, so yeah, so this is what the X train looks like and the X test looks like, which is smaller than the training data. So, and then this is the Y train and the Y test using the one hot encoding. The MPI essentially turns it into is the or I guess the best way if you want to run it into one hot encoding, it makes a matrix. It's how we made the matrix for creating since there's like there's 100 different classes. It creates the data with 100 rows with its label. So you can see. And then for this part, this is more into for the assignment specifically. So we have a dictionary with parameters. So since it's hyperparameter training, we initialize our parameters inside of a dictionary and then loop through to use them whenever we're training to find the using the cross validation to find the best parameters for our for training the model. So we had 120, 240 units, ReLU sigmoid, softmax, sigmoid, MSE, categorical cross entropy, and then atom eta grade, and then our batch sizes, which is 1,000, 2,000. See, so this function here that we've created is our model, which is the MLP. So we have the X train, the Y train one hot encoding, X value, Y value for one hot encoding, and the index and parameters. And then this is use cross entropy here. So if the parameters dictionary is equal to cross entropy, or it sets the parameters of loss to the categorical cross entropy. And then this is our activation function. Use a sigmoid if the parameters is equal to sigmoid, or in the the prior's activation is equal to sigmoid, then else it uses the ReLU, the linear regression. So for our model, we have the NN.linear. So this is 3072, which for our images features is essentially just 32 times 32 times 3, which is equal to 3072. So um, that's our input. And then I did it where I just divided them by 2 for most of them. I did get down to 384, and for this assignment we needed to use our parameters right before our output, so I felt like it was good to test 384 whatever. It's 240 so that we could see when it's like where the layers are too close to each other or if they're too far from the output. Since our output's 100 because there's 100 classes. So it'll only make sense and then uses our device. Um, we have our optimizer, so which essentially just uses Atom, else use Atagrade, and then our criterion binary cross entropy loss, then UCE, once UCE is the categorical cross entropy, then else use mean squared error as our loss function. This is for loading in the tensor data set and the loader and shuffles it using our batch size params. Let's see. And then this is for actually training our data. So we have 200 epochs, which is quite a lot. And then our batches that are loaded in the loader uses our optimizer, our output uses loss with our output in the Y batch. And then we have the evaluate. Hmm. And then we return an accuracy that's rounded for places and the value accuracy for the cross validation, which will allow us to see if the model is overfitting or underfitting. Let's see. And then this is essentially just for printing it out and then making a directory and writing it to a CSV. To be honest, I had ran this for about 6 hours and wasn't able to get through 200. And even with this, the data wasn't very good. So my highest point was actually this very first one, funny enough, using the ReLU as my hidden activation, 120 units, soft, or excuse me, ReLU is my hidden activation, softmax was my activation, and then using mean squared error, and then the Atom optimizer with 1,000 being our batch size. And so you can see it keeps looping through and testing different parameters, and we can validate them with their accuracy and their value accuracy. Which once I got to 240, it struggled quite a lot. It did a lot of guessing, but occasionally you would hit fairly well. But that's pretty much it uh for this assignment for testing the hyperparameters. So yeah.